The cosmos holds secrets more bizarre than any science fiction. We are about to journey to the 25 strangest objects ever discovered in space. You will see cosmic cannibals, phantom particles, and interstellar visitors that challenge our understanding of reality. How can a star simply vanish for decades only to return? What force is pulling our entire galaxy toward an unseen abyss? By the end of this exploration, you will know the universe is far stranger and more wonderful than you ever dreamed. What cosmic mystery captures your imagination the most? Deep in the constellation Sagittarius, a cosmic predator is slowly consuming its partner. This is the Black Widow pulsar, a rapidly spinning stellar corpse whose deadly embrace is unraveling a neighboring star. It earns its name from the female Black Widow spider, known for devouring its mate. This pulsar is a neutron star, the incredibly dense remnant of a supernova explosion, spinning hundreds of times every second. Such objects are called millisecond pulsars, and they emit powerful beams of radiation and relentless winds of charged particles. The Black Widow is not alone. It exists in a binary system with a small, lightweight star locked in a tight orbit. The pulsar's intense energy blasts the facing side of its companion, heating it to extreme temperatures and literally boiling away its outer layers. Imagine a star being slowly sandblasted by a cosmic fire hose of radiation, its mass streaming away into space. This stolen matter forms a vast, shimmering cloud of plasma around the system, a visible testament to the destruction. Over millions of years, this process will completely strip the companion star, leaving behind only a ghost of its former self. The pulsar, having gained energy from this cosmic feast, will spin even faster, a silent killer drifting alone through the void. It is a stark reminder that even among the stars, there are forces of breathtaking beauty and absolute lethality. Yet even the destructive dance of the Black Widow pulsar follows a certain cosmic logic. When we look at Hoag's object, however, that logic seems to break down entirely. This is a galaxy that looks more like a piece of celestial jewelry than a star system, a nearly perfect ring of brilliant blue stars encircling a golden core. Between them lies a vast, dark gap that appears almost completely empty, creating a structure so symmetrical it feels artificial. It is as if someone painted a giant cosmic bullseye across the void. The central core is a dense sphere of ancient yellow stars calmly burning for billions of years. Surrounding it is a perfect detached ring of younger, hot blue stars, a celestial halo of stellar newborns. The most baffling part is the profound darkness separating the two, a chasm so clean it defies easy explanation. How could such a perfect structure form? The leading theory suggests a galactic collision billions of years ago, where a smaller galaxy shot straight through the heart of a larger one. Like a stone dropped into a pond, this event could have sent ripples of gas and dust outward, triggering a wave of new star formation in a perfect ring while leaving the central core undisturbed. Another idea points to an unstable density wave, a gravitational ripple that compresses gas to form stars in a circular pattern. But neither theory is a perfect fit, leaving astronomers puzzled by this cosmic enigma. Hoag's object stands alone, a serene and mysterious anomaly that challenges our very understanding of how galaxies are built. While Hoag's object presents a perfect ring on a galactic scale, another cosmic structure offers geometric perfection on a far more intimate and equally baffling level. The Red Rectangle Nebula is precisely what its name suggests, a glowing red celestial object that appears to have sharp, rectangular corners. Most nebulae are known for their flowing, ethereal shapes, great clouds of gas and dust sculpted by chaotic stellar winds. This one defies all such expectations, looking instead like a piece of abstract art or a glowing ladder seen from the side. At its heart lies a dying star, a sun-like star in its final act. This is a protoplanetary nebula, a brief and beautiful phase where the star has stopped burning fuel in its core and has begun to shed its outer layers into space. What we are witnessing is the star's funeral shroud being woven, but woven into a shape that seems impossibly structured. The secret to its form lies not in the star itself, but in a dense, donut-shaped ring of dust that encircles it. Think of this ring as a cosmic stencil. As the star expels its material in all directions, the densest parts of this dust torus block the outflow, forcing the gas to escape above and below the ring. This creates two opposing cones of ejected material, and from our vantage point on Earth, we are looking directly down the barrel of one of these cones. The edges of these cones, illuminated by the central star's light, create the illusion of a series of glowing red rectangles, a cosmic optical illusion of stunning precision. The mysterious red glow itself comes from a substance known as unidentified infrared emission bands, complex carbon molecules that fluoresce under the star's intense ultraviolet radiation. This entire system is a temporary masterpiece, a fleeting stage in a star's death that will soon fade, leaving behind only a white dwarf and an expanding cloud of cosmic dust. It is a perfect geometric echo of a star's final breath. But for all the geometric perfection of the red rectangle, there is another cosmic mystery where the strangeness is not in its shape, but in its behavior. A star named Tabby Star began to act in a way no one had ever seen. Orbited by our Kepler Space Telescope, this seemingly ordinary star started to flicker and fade in an absolutely bizarre pattern. Most stars with planets show tiny, regular dips in brightness, a telltale sign of an orbiting world passing in front of them. These dips are usually less than 1%. Tabby's star, however, did nothing of the sort. Its light would plummet by enormous amounts, up to 22%, as if something colossal was drifting in front of it. Then, just as strangely, it would return to normal. These dimming events were not periodic. They were erratic, unpredictable, and on a scale that defied any conventional explanation. A planet, even a giant one, could never block that much light. The object or objects causing this had to be immense, and they were moving in a way that suggested a chaotic, fragmented cloud rather than a single, solid body. The most tantalizing and ultimately sensational theory proposed that we were witnessing the construction of an alien megastructure. The idea was that an advanced civilization might be building a vast array of solar collectors, a Dyson swarm, around their sun to harness its energy. The irregular dimming could be the shadows cast by these colossal, partially completed constructs. While astronomers always considered this the least likely possibility, it captured the world's imagination because it was, for a brief moment, a scientifically plausible hint of intelligence beyond our own. The more probable explanations are natural, yet still deeply strange. One leading idea is a vast, swirling swarm of comets, thousands of them, on long, eccentric orbits that occasionally cluster together to block the star's light. Another suggests the lingering debris from a cataclysmic planetary collision, a cloud of dust and rock slowly spiraling around the star. Recent observations point towards uneven clouds of interstellar dust, which can clump and disperse as the primary culprit. Yet the precise nature of this dust and why it behaves so erratically remains an active puzzle. Tabby Star stands as a powerful reminder that the universe is full of natural phenomena we have yet to imagine, where the line between the impossible and the merely unexplained is wonderfully, thrillingly thin. While the dimming of Tabby Star posed one kind of puzzle, a different and far more energetic mystery was already screaming across the cosmos. From the depths of space come flashes of radio waves so powerful they outshine entire galaxies, yet they last for less than the blink of an eye. These are fast radio bursts, and one in particular, known as FRB 121102, changed everything we thought we knew about them. Before its discovery, all known fast radio bursts were one-off events, a single, spectacular flash of radio energy from a random point in the sky, never to be heard from again. This made them nearly impossible to pin down, but FRB 121102 was different. It repeated. It sent out multiple bursts from the exact same location, giving astronomers a precious chance to finally track one of these phantoms to its home. The source was not in a majestic spiral galaxy like our own Milky Way. It was traced to an unassuming, tiny dwarf galaxy, an almost incomprehensible 3 billion light-years away. That distance is the first clue to the sheer power involved. For a burst to be detectable across such a vast gulf of space, the energy released in that single millisecond must be staggering, equivalent to what our sun puts out over several decades. So what cosmic engine could possibly produce such a violent, fleeting, and yet repeating signal? The prime suspect is a type of neutron star called a magnetar. These are the universe's ultimate magnets, stellar corpses with magnetic fields so intense they could erase a credit card from halfway to the moon. A starquake on the surface of a magnetar, a sudden cracking of its rigid crust, could theoretically unleash a titanic shockwave, rippling out into space as one of these brilliant radio flashes. But the repeating nature of FRB 121102 complicates this simple picture. Could a single magnetar have starquakes violent enough and frequent enough to explain the many bursts we have observed? Some scientists speculate the bursts might be generated by a magnetar in orbit around a massive, volatile star, with interactions between their powerful stellar winds creating the perfect conditions for periodic eruptions. Others wonder if we are seeing the energetic beams from a young, hyperactive pulsar as it sweeps past our line of sight. The true cause remains one of the biggest open questions in astronomy, a reminder that the universe is capable of generating phenomena of raw, explosive power that we are only just beginning to detect. If you thought fast radio bursts were fleeting, another cosmic event redefined what we thought was possible in an instant. In June of 2018, a tidal wave of light erupted in a galaxy 200 million light-years away. Astronomers designated it at 2018 Cow, a name derived from the random letters in its catalog number, but its sheer ferocity quickly earned it the simple, memorable nickname the Cow. This was no ordinary stellar explosion. It brightened with unbelievable speed, reaching peak luminosity in just a few days, a process that takes most supernova weeks. For a brief period, it shone with the light of nearly 100 billion suns, outshining its entire host galaxy before it began to fade away just as rapidly. This incredible flash of light was packed with high-energy radiation, from X-rays to radio waves, a broad-spectrum blast that left astronomers stunned. It was far too fast and far too bright to be a typical supernova. The expanding shell of debris was moving at a staggering 20,000 kilometers per second, a significant fraction of the speed of light. What kind of explosion could possibly launch material at such velocities? The leading theory points to the birth of a black hole. In this scenario, a massive star collapsed not with a slow burn, but in a sudden, catastrophic implosion. The core of the star instantly formed a black hole or a highly magnetic neutron star, and the infalling stellar material created a swirling, ultra-hot accretion disk around it. The immense energy released from this violent feast, beamed directly into space, could explain the Cow's intense and rapid flash. Another compelling idea suggests a white dwarf star being shredded by a black hole or a neutron star. The tidal forces would rip the dense stellar remnant apart, creating a similar, brilliant flash of light as the stellar material is consumed. Whatever its true origin, the Cow was a landmark discovery. It was not a fluke, it was the first of a new class of objects now known as fast blue optical transients. These are cosmic explosions that are over in a flash, brilliant blue beacons signaling some of the most extreme and violent births in the universe. The cow forced us to look closer, to realize that the final moments of a star can be far more varied and explosive than we ever knew. Our galaxy is not simply drifting in the void, it is being pulled. The Milky Way, along with every other galaxy in our local neighborhood, is racing at an astonishing 2 million kilometers per hour toward a specific point in the cosmos, a mysterious region of immense gravity known as the Great Attractor. This is not a single object, but a colossal gravitational anomaly, a focal point in the fabric of space that draws everything toward it. For decades, its true nature was hidden from our view, located in a direction that lies behind the crowded, dusty central plane of our own galaxy. Astronomers call this region the zone of avoidance because the thick bands of stars, gas, and dust of the Milky Way's bulge effectively blind our optical telescopes, creating a cosmic blind spot that perfectly concealed the universe's most powerful tug. It was like trying to see a distant mountain range through a dense, permanent fog. To solve this mystery, scientists had to look with different eyes. They turned to X-ray and radio telescopes, instruments that can pierce through the obscuring interstellar veil. What they finally saw was not a single, impossible structure, but something almost as profound. The core of the Great Attractor's pull is centered on a massive supercluster of galaxies called the Oumuamua cluster. This is a dense, rich knot of hundreds of galaxies, all bound together by gravity, forming a concentration of mass so immense that its gravitational influence dominates our entire corner of the universe. Our local group, which includes the Milky Way and Andromeda galaxies, along with the entire Virgo supercluster, are all part of this vast cosmic river flowing toward this gravitational heart. Yet, even the Oumuamua cluster does not fully account for the tremendous speed of our motion. The Great Attractor itself seems to be moving, pulled toward something even larger and more distant, a structure known as the Shapley supercluster, the greatest concentration of mass in our observable universe. So the Great Attractor is not an ultimate destination, but a waypoint in an even grander cosmic current, a reminder that on the largest scales, the universe is a web of invisible forces guiding the motion of galaxies in a silent, relentless flow. This cosmic flow toward the Great Attractor reveals a universe structured by immense concentrations of mass. But what happens when we look toward a place that is almost nothing at all? In the constellation of Boötes, there exists a region of space so profoundly empty it has earned the name the Boötes Void, often called the Great Nothing. This is not a simple gap between galaxy clusters, it is a cosmic chasm of staggering proportions, a spherical region roughly 330 million light-years across. To grasp that scale, if you placed our Milky Way galaxy at its center, the nearest edge of this void would be over 165 million light-years away in every direction. In a universe that is supposed to be filled with a vast web-like structure of galaxies, this void is a gaping hole, a desert of unbelievable size. Its existence directly challenges our models of how the cosmos formed after the Big Bang. The distribution of matter should be somewhat even, like a froth of bubbles, but the Boötes Void is a bubble so vast it seems to defy the very rules of that cosmic foam. It is not completely empty, but what little is there only deepens the mystery. Scattered across this incredible emptiness are a few dozen isolated galaxies, like lonely ships adrift in an ocean of nothingness. These galaxies are not grouped into clusters, they are solitary points of light, each one an island universe shining in an immense dark sea. How did such a vast nothingness come to be? One leading theory suggests it is the result of smaller voids merging together over billions of years, like soap bubbles coalescing into one giant bubble, pushing the galaxies out toward the edges. Another, more profound idea is that the Boötes Void is a primordial anomaly. Its seed may have been planted in the first moments of the universe, a region that was simply born with far less density than the space around it. As the cosmos expanded, this initial fluctuation grew into the colossal emptiness we detect today. The void stands as a silent challenge, a reminder that the architecture of the universe holds absences as profound as its presences. The search for alien megastructures did not end with Tabby Star. Another sun, known as Epic 204278916, presented an even more dramatic light show. This young, sun-like star did something that stunned astronomers, its light suddenly plummeting by a staggering 65%. This was not a series of flickers, but one deep, precipitous drop, as if a colossal, opaque object had drifted directly between the star and our telescopes. A single planet, even a gas giant, could never block that much light. The scale of the obstruction was simply mind-boggling, reigniting the tantalizing speculation about intelligent life. Could this be the shadow of a Dyson sphere under construction, a vast array of orbiting solar panels designed to capture a star's entire energy output? The idea was intoxicating, a potential signature of a civilization so advanced it could restructure its own solar system. Yet science must always seek natural explanations first, and for Epic 204278916, a compelling one emerged from its youth. This star is surrounded by a dense, spinning disk of gas and dust, the very material from which planets are born. Astronomers theorize this disk is not perfectly flat. It could be warped, perhaps by the gravitational pull of an unseen planet, creating a vast, lopsided inner rim. If we happen to be viewing this system nearly edge-on, that warped, dusty inner edge could have swung directly in front of the star, blocking its light for a short period and creating that astonishing 65% dip. Another possibility involves a truly epic celestial migration. A family of exocomets, thousands or even millions of them, could be on a long, falling orbit toward their star. As they draw closer, the intense heat would cause them to disintegrate, releasing enormous clouds of dust and debris. A swarm of these disintegrating comets passing in front of the star would create a dense, temporary shroud, perfectly capable of causing such a profound dimming. While these natural theories are far more likely, the profound mystery of Epic 204278916 serves a vital purpose. It pushes our imagination to its limits and refines our search, teaching us what to look for in the data. It reminds us that the universe, in its natural complexity, can produce signals so strange they border on science fiction, forcing us to ask the most profound question of all. Are we alone? While we ponder the youthful chaos of forming solar systems, we encounter a cosmic relic that seems frozen in time. NGC 1277 is a galaxy that has not changed for 10 billion years, a living fossil from the dawn of the universe. This ancient cannibal galaxy has not created a single new star in all that time. Its stellar population composed entirely of old, red suns that formed in a single, frantic burst of creation. It is a ghost of a past era, a museum piece on a galactic scale. The reason for its arrested development lies in its heart, where a discovery shattered all expectations. Nestled at its core is a supermassive black hole of almost incomprehensible proportions. While most galaxies, including our own Milky Way, have central black holes that make up a tiny fraction of their total mass, the behemoth in NGC 1277 is different. It is a colossus, accounting for a staggering 1/5 of the entire galaxy's mass. This is not a simple imbalance, it is a cosmic anomaly. Imagine if the Sun contained more mass than all the planets, asteroids, and comets in our solar system combined. That is the scale of the disproportion we are witnessing. This black hole is so massive that it seems to have strangled its own galaxy. The prevailing theory of galaxy evolution suggests a symbiotic relationship where a black hole and its host galaxy grow together. But here, the black hole grew too fast and too large too early. Its immense gravitational pull likely consumed or expelled the vast reservoirs of cold gas required to form new stars, essentially eating the galaxy's future. NGC 1277 represents a path of cosmic evolution that was cut short, a galaxy that cannibalized its own potential for growth and now drifts as a silent, red testament to a different, more violent beginning. After the silent, red giants of cosmic history, we find a world born from stellar catastrophe. Circling the corpse of a dead star is a planet unlike any other, a world that may be one giant diamond in the sky. Known as PSRJ 17191438b, this exotic world orbits a pulsar, the rapidly spinning remnant of a supernova explosion. The planet itself is the ghost of a star that was not quite massive enough to become a pulsar itself. It began its life as a white dwarf star, the dense, Earth-sized core of a sun-like star. This white dwarf was locked in a tight, doomed dance with its pulsar companion. Over eons, the pulsar's intense gravity siphoned away more than 99% of the white dwarf's mass, stripping it down to its bare, carbon-rich core. The pressures involved in this process are almost beyond comprehension, crushing the remaining carbon so intensely that its atomic structure was forced to crystallize. The result is a planet with a mass greater than that of Jupiter, yet compressed into an object less than half its size, a celestial body that is likely a solid, Earth-sized diamond. How could we possibly detect such a strange object? The answer lies in the clockwork precision of its pulsar host. Pulsars spin with incredible regularity, their beams of radio waves sweeping across space like a cosmic lighthouse. Astronomers detected tiny, systematic variations in the timing of these pulses, a rhythmic wobble betraying the gentle gravitational tug of an unseen orbiting world. By measuring the subtle timing of these flashes, they could deduce the planet's mass and orbit. This diamond world is not a glittering jewel in the traditional sense. Its surface would be dark and incredibly dense. Yet its existence reveals the astonishing diversity of planetary outcomes. It is a testament to stellar cannibalism and transformation, a remnant core forged in a stellar furnace and then crystallized under unimaginable pressure, a diamond planet orbiting the ghost of the star that created it. The diamond world forged from a dead star shows how strange planets can become. But what about an object that is not from any star system at all? In October 2017, astronomers detected a visitor from the void, the first known object to journey from interstellar space into our solar system. They named it Oumuamua, a Hawaiian word meaning scout or messenger from the distant past. This mysterious traveler was already speeding away from the sun by the time we spotted it, a dark, reddish object whose properties immediately defied classification. Its path was not bound to our sun, marking it as a true interstellar wanderer. The first surprise was its shape. Unlike most asteroids and comets, which are roughly spherical or lumpy, Oumuamua was dramatically elongated. Estimates suggest it was up to 10 times longer than it was wide, a tumbling cosmic cigar or perhaps a flat pancake tumbling through the void. This was an unprecedented form for a natural space object. Then came the real puzzle, its motion. As Oumuamua sped away from the sun, its trajectory could not be explained by gravity alone. It was experiencing a slight but persistent non-gravitational acceleration, a gentle push that was making it move faster than it should. Comets often exhibit non-gravitational acceleration when ices on their surface heat up and vent jets of gas, forming a glowing coma and a tail. Yet Oumuamua showed no such activity. Our most powerful telescopes detected no dust, no gas, no coma whatsoever around it. It was accelerating in total silence. This combination of facts, its strange shape, its mysterious acceleration, and its complete lack of outgassing, ignited a fierce scientific debate. What was this thing made of? One compelling theory posits that Oumuamua is a fractal dust aggregate, an extremely porous and low-density object like a cosmic snowflake. Its delicate structure could have been shaped by eons of travel through interstellar space, and its acceleration could be explained by the gentle pressure of sunlight itself pushing against its large, light surface. Another idea suggests it is a nitrogen iceberg, a chunk of solid nitrogen that was chipped off the surface of a Pluto-like world in a distant solar system. As it passed close to our Sun, the solar heat could have caused the nitrogen to sublimate, turning directly from a solid to a gas, providing the thrust for its acceleration without releasing the dusty debris that would form a visible coma. Then there is the more speculative and highly publicized theory proposed by astrophysicist Avi Loeb. He posits that Oumuamua's unusual acceleration and its peculiar shape are consistent with it being an artificial object, specifically a light sail. A light sail is a proposed form of spacecraft propulsion that uses the subtle pressure of sunlight to navigate through space, much like a boat sail uses wind. In this scenario, Oumuamua would not be a rock or an iceberg, but a piece of advanced technology, either a derelict probe or a discarded fragment from an alien civilization. While the vast majority of astronomers favor a natural explanation, citing the principle that you should not attribute something to aliens when natural processes can explain it, the mystery of Oumuamua remains potent. It forced science to confront an entirely new class of object, proving that interstellar space is filled with travelers we are only beginning to understand. That mysterious acceleration as it departed remains the deepest puzzle of Oumuamua. If it were a simple asteroid, its path away from the Sun would be governed purely by gravity, a predictable arc slowing as it climbed from the Sun's gravitational well. But Oumuamua was not slowing down as expected. It was speeding up, as if given a gentle, continuous push. The most logical explanation for such behavior in a cosmic object is outgassing, the same process that gives comets their beautiful tails. When a comet's icy surface heats up near a star, it vents gas and dust into space. This acts like a natural rocket engine, providing the non-gravitational thrust that can alter its course. Yet when every telescope was trained on Oumuamua, they saw nothing. No cloud of gas, no dusty halo, no tail whatsoever. It was accelerating in utter silence, a stealthy push with no visible exhaust. This contradiction forced scientists to propose some truly exotic ideas. One fascinating theory suggests Oumuamua was a hydrogen iceberg. In the cold, dense cores of giant molecular clouds where new stars are born, conditions might be right for chunks of solid hydrogen to form. A block of frozen hydrogen would be nearly invisible to our telescopes. As it approached our Sun and warmed up, the hydrogen would sublimate, turning directly from a solid to a gas, providing the necessary thrust for acceleration. Because molecular hydrogen is invisible in the wavelengths we typically observe, this outgassing would leave no detectable trace, perfectly explaining the silent push. Yet the survival of such a fragile hydrogen iceberg on its long journey between stars is a major point of debate, as it would likely evaporate long before reaching us. Another compelling idea paints an even stranger picture, that Oumuamua was not a solid chunk at all, but an incredibly porous fractal dust aggregate. Imagine a cosmic snowflake, a delicate structure of dust and ice with more empty space than solid material, a celestial sponge. This object would have a very low density and a very large surface area for its mass. In this scenario, the pressure of sunlight itself, the gentle but constant push of photons from the Sun, could be enough to act as a sail, providing the acceleration we observe. Its bizarre, elongated shape could even be a result of this fragile construction, whittled down by eons of interstellar travel. Whether a ghostly iceberg or a celestial snowflake, Oumuamua's true nature pushes the boundaries of what we consider a normal celestial object, a silent messenger that left us with more questions than answers. While Oumuamua was a silent, solid enigma, another messenger from the depths of space is so ethereal it can pass through entire planets unnoticed. This is the neutrino, often called the ghost particle. Trillions of them stream through your body every second, coming from the Sun and distant cosmic events, yet they almost never interact with anything. They are phantoms of the subatomic world, making them incredibly difficult to catch. In September 2017, one of these phantoms did something extraordinary. It slammed into the Antarctic ice with tremendous force. This was no ordinary neutrino. It carried an immense amount of energy, signaling it came from a source of unimaginable violence far beyond our galaxy. It was detected by a remarkable observatory known as IceCube, which is not a building but a colossal instrument buried deep within the polar ice. IceCube consists of thousands of sensitive optical sensors strung along cables that descend more than a mile into the glacier, turning a cubic kilometer of pristine ice into a particle detector. When that single high-energy neutrino struck an atom in the ice, it created a secondary particle that gave off a faint, telltale blue glow as it traveled. This flash of light captured by the sensors allowed scientists to trace the neutrino's path back to a specific point in the sky. That point was a blazar, a monster lurking 4.5 billion light-years away. A blazar is the core of a distant galaxy, powered by a supermassive black hole that is actively feeding on surrounding material. As matter spirals into the black hole at near light speed, it heats up and creates powerful jets of radiation and particles that shoot out into space. We on Earth just happen to be looking directly down the barrel of one of these ultra-relativistic jets, a cosmic blowtorch aimed right at us. This single detection, named IceCube 170922A, was a landmark event. For the first time, scientists had used a ghostly neutrino to pinpoint a specific, cataclysmic event in the distant universe. This marked the triumphant birth of multi-messenger astronomy, a new way of seeing the cosmos. Instead of relying on light alone, we can now combine its information with other cosmic messengers, like gravitational waves and these elusive particles. Each one tells a different part of the story, giving us a more complete picture of the universe's most energetic processes. To catch a single ghost particle and follow its trail billions of light-years back to a raging black hole is a testament to human ingenuity, proving that even the most elusive messengers can no longer hide their cosmic origins. This stellar heartbeat is a rhythm born of gravitational violence. Meet Macho 80.744 3.1718, a binary star system where two massive, luminous stars are locked in such a close, frantic orbit that they complete a full cycle in just under 32 days. With each pass, the gravitational pull of one star violently squeezes and distorts its partner, causing the entire star to pulsate like a colossal, glowing heart. This is not a simple eclipse where one star passes in front of the other. Instead, the star itself is being physically deformed, its outer layers pulled into a teardrop shape before snapping back, a process that changes its brightness by a dramatic 20%. Imagine holding a soft stress ball in your hand and rhythmically squeezing it. As you compress it, its surface area changes, and if it were glowing, its light would pulse in time with your grip. That is precisely what is happening on a stellar scale, a gravitational squeeze that makes the star swell and contract. These heartbeat stars offer a unique laboratory for studying tidal forces, the same kind of gravitational tug that our moon exerts on Earth's oceans, but amplified to an almost destructive degree. The data from these systems allows astronomers to peer into the internal structure of stars, understanding how their mass is distributed and how they respond to extreme stress. This cosmic dance is temporary. As the stars continue their intimate waltz, they are likely trading mass and energy, a process that will ultimately alter their fates, potentially leading to a spectacular merger or a double supernova. The heartbeat is a fleeting rhythm in a long stellar life, a visible, pounding testament to the invisible force of gravity that binds the cosmos together. Deep in the crowded heart of our galaxy, a new class of cosmic elder has been found hiding in plain sight. These are the old smoker stars, ancient red giants that engage in a bizarre ritual of cosmic exhalation. For years, they appeared perfectly normal in telescope surveys, but recent observations revealed their secret. They are not constant beacons, they are variable stars with a unique and dramatic habit. Every few decades, an old smoker will seem to take a deep cosmic breath and then puff out an immense opaque cloud of dust. This cloud is so thick and vast that it enshrouds the entire star, causing its visible light to dim dramatically, sometimes by up to 97%, nearly vanishing from view for months or even years before the cloud dissipates and the star reappears. This behavior is completely unlike any other known type of pulsating or eclipsing variable star. It is not a regular rhythm or an external eclipse, it is a slow internal eruption. Astronomers believe the process begins deep within the star's atmosphere. In their advanced age, these red giants have accumulated a significant amount of heavy elements in their outer layers. Under the right conditions, these elements can cool and condense into solid dust grains like soot forming in a chimney. Once a critical amount of dust accumulates, it is ejected outward by the pressure of the star's own light, creating a temporary sun-blocking shroud. This discovery is far more than a celestial curiosity. It is a key piece in the galactic cycle of life and death. These old smokers are essentially galactic recyclers. The dust clouds they puff out are rich in critical elements like carbon, oxygen, and iron, the very building blocks of rocky planets and life itself. For billions of years, these ancient stars have been quietly seeding the interstellar medium with these essential ingredients. Every time an old smoker has a puff, it is enriching the cosmic neighborhood, contributing the raw materials for future generations of stars, planets, and perhaps even living organisms. They are the quiet, elderly gardeners of the galaxy, slowly and methodically fertilizing the cosmos with the elements of creation. This cosmic recycling process is a slow and patient one. Each time an old smoker star exhales one of its vast dust clouds, it is seeding the surrounding space with a specific mix of heavy elements. We are talking about carbon, the fundamental backbone of life as we know it. We are talking about oxygen, the breath of planets, and iron, the very element that gives our blood its color and our planet its magnetic field. These are not just abstract chemicals, they are the literal building blocks for everything solid and living. When a new generation of stars and planets coalesces from a cloud of interstellar gas and dust, that cloud will be sprinkled with the enriched material from these ancient stellar eruptions. The rocky world you stand on, the iron in your blood, the carbon in your body, all of it was once forged in the heart of a long-dead star and likely distributed by a process just like this. These old smokers are the galactic supply chain, the delivery system for the ingredients of worlds. Their peculiar eruption mechanism is a key puzzle in stellar geriatrics. For a star like our own sun, this is a preview of a distant future. In billions of years, our sun will swell into a red giant, and while it may not become an old smoker specifically, it will undergo its own process of shedding its outer layers. By studying why and how these old stars suddenly decide to puff out these immense shrouds, we are essentially reading the final chapters in the life story of a typical star. It helps us understand the delicate balance in a star's atmosphere, where temperature and pressure can suddenly tip toward creating solid dust right above the stellar surface. This is more than a curiosity, it is a crucial piece of the galaxy's chemical evolution. Every element heavier than hydrogen and helium had to be made somewhere, and the old smokers represent a vital, and until recently hidden, method of distributing those elements across the Milky Way. They are the quiet, steadfast gardeners ensuring that the galaxy remains fertile, that from the ashes of old stars, new ones can always be born. A star is racing for its life. Zeta Ophiuchi is a blue giant behemoth, a stellar titan currently plowing through a dense cloud of interstellar gas and dust at an almost incomprehensible speed of 24,000 kilometers per hour. This is not a gentle journey, it is a violent, high-speed collision with the fabric of space itself. You can see the evidence of this frantic escape in stunning infrared images, which reveal a colossal, glowing wave of compressed material arcing in front of the star, a structure known as a bow shock. This is the cosmic equivalent of the wave that forms at the prow of a speedboat, a brilliant, curved wall of light created as the star's powerful stellar wind and its immense gravitational field slam into the surrounding cosmic medium. The star is literally pushing the universe out of its way. How did such a massive object achieve such incredible velocity? The most compelling theory is one of cosmic betrayal and a violent birth. Astronomers believe Zeta Ophiuchi was not always alone. It was likely once the smaller partner in a binary star system, locked in a gravitational dance with an even more massive and volatile companion. That partnership ended in a cataclysm. The larger star, burning through its nuclear fuel at a prodigious rate, reached the end of its life and exploded as a supernova. Such a titanic detonation is rarely symmetrical. If the explosion is lopsided, it can literally kick the surviving companion star, sending it flying out of the system like a stone from a slingshot. In this scenario, the supernova's blast wave would have instantly shredded the gravitational bond between the two stars, ejecting Zeta Ophiuchi at its tremendous speed, while the core of the exploded star collapsed into a neutron star or black hole, now drifting in the opposite direction. As this runaway star tears through the galaxy, it is not just a passive traveler, it is an active agent of change. Its fierce ultraviolet radiation and powerful winds heat and compress the gas clouds it encounters, potentially triggering new waves of star formation in its wake. Furthermore, the star itself is a factory for heavy elements, forging atoms like oxygen and silicon in its core. When it eventually meets its own violent end as a supernova, it will scatter these enriched materials far and wide, seeding future generations of stars and planets. Zeta Ophiuchi is a fugitive, a testament to the explosive forces that can reshape stellar destinies and scatter the seeds of creation across the cosmos. Even as we chart the motion of our galaxy toward the Great Attractor, a deeper and more controversial current was proposed, one that seemed to pull at the very fabric of the known universe. In the early 2000s, a team of astronomers made a startling claim after studying the cosmic microwave background, the faint afterglow of the Big Bang. This relic radiation fills all of space, a nearly uniform sea of microwaves. But by analyzing data from the Wilkinson Microwave Anisotropy probe, they detected a subtle, unexpected pattern. Huge clusters of galaxies, numbering in the thousands, appeared to be moving in a coherent stream at phenomenal speeds, all heading toward the same specific patch of the cosmos. This motion was separate from the universe's overall expansion and could not be explained by the gravitational pull of any known structure. Not the Great Attractor, not the Shapley supercluster, nothing within our observable horizon. They called this phenomenon the dark flow. The method itself was ingenious. It relied on the kinetic Sunyaev-Zeldovich effect, a subtle distortion in the cosmic microwave background caused by the motion of these gigantic galaxy clusters. As the clusters move, they scatter the microwaves in a way that reveals their velocity and direction. The signal was faint, but the team insisted it was real, a vast river of galaxies flowing toward something unimaginably large and distant. The implications were staggering. If this flow was real, its source had to lie beyond the edge of our observable universe. The most mind-bending possibility was that the dark flow was the gravitational tug of a massive structure in a neighboring universe, or a region of space-time so far away that its light has not had time to reach us since the beginning of time. It was a hint that our cosmos might be just one island in a much vaster multiverse, and that we could feel the tides from shores we could never see. This claim, as you can imagine, sparked intense debate and skepticism within the scientific community. Other teams analyzed the data and found different results, arguing that the statistical methods were flawed or that the signal was not significant enough to prove such an extraordinary claim. Later, more precise data from the Planck satellite failed to confirm the original dark flow detection, casting serious doubt on its existence. While the evidence for the dark flow has largely faded, its legacy endures. It pushed our methods of observation to their absolute limits and forced us to confront a profound question. If we ever did detect a motion that pointed beyond our cosmic horizon, how would we ever prove what lies in the unseeable dark? Out in the asteroid belt, an object known as Pulsar follows all the rules of a typical asteroid, tracing a stable, circular path around the Sun. Then, for reasons we cannot predict, it breaks those rules completely, sprouting a faint but definite tail of gas and dust, just like a comet. This bizarre hybrid is a main belt comet, a category of object that should not logically exist. The asteroid belt, located between the orbits of Mars and Jupiter, is a region of intense heat and solar radiation, a place where any surface ice should have been boiled away billions of years ago. So how can Pulsar suddenly and sporadically produce a tail? The answer seems to lie hidden beneath its surface. One compelling theory is that we are witnessing the aftermath of a recent cosmic collision. A smaller asteroid could have slammed into Pulsar, blasting away its ancient, dusty surface layer and exposing a hidden reservoir of subsurface ice. When a patch of this pristine ice is exposed to the vacuum of space and the sun's warmth, it instantly turns from a solid to a gas in a process called sublimation. This venting gas pulls dust grains along with it, creating the temporary, ghostly coma and tail we observe. It is a slow, cosmic bleed from a recent wound. Another possibility is even more intriguing, suggesting that Pulsar is not an asteroid at all, but a true comet that was captured in the asteroid belt long ago during the solar system's violent and chaotic youth. In this ancient era, the giant planets were still migrating, and their immense gravity could have flung a comet from the distant Kuiper belt inward, trapping it in a stable, asteroid-like orbit. There, its volatile ices were buried deep beneath a thick, dark crust of dust and rock, a protective blanket that has preserved them for eons. Occasional shifts in this crust, perhaps from the subtle warming of a close pass by the sun, could open fresh fissures, allowing the ancient ice to vent into space. This makes Pulsar a time capsule, holding frozen material from the very dawn of our planetary system, a relic of a time when the architecture of our solar system was still being decided. The existence of Pulsar shatters the old map of our solar system, a map that placed a strict, dry boundary between the inner rocky worlds and the outer icy realms. This main belt comet is not a solitary oddity, but a herald of a hidden population, proving that vast reservoirs of water ice can survive just next door in the scorching heat of the asteroid belt. For decades, the prevailing theory of our planet's water suggested it arrived late, delivered by a bombardment of comets and asteroids from the frozen outskirts of the solar system. But what if the building blocks of Earth's oceans were much closer all along? Objects like Pulsar suggest that water was a local product, baked into the very fabric of the inner solar system from the beginning. The primordial disk of gas and dust that formed our planets was likely not a simple gradient from hot to cold. Instead, it may have been a patchwork with frigid, ice-rich material mixing inward, becoming trapped within the forming asteroids. These icy bodies then became the bricks that built the terrestrial planets, with Earth's water potentially arriving not from a distant, random delivery, but as an inherent part of its own construction material. This radically changes our understanding of our own origins. If water was a common local ingredient, then every rocky planet forming in the habitable zone of a star might start with its own built-in supply, dramatically increasing the chances for life to emerge across the cosmos. Furthermore, the implications reach beyond our own blue planet. If countless asteroids in the main belt contain subsurface oceans protected by a thick, insulating layer of rock and dust, they become miniature worlds with potentially habitable environments. The internal heat from radioactive decay, combined with the insulating properties of their rocky shells, could maintain liquid water pockets for billions of years. We see this principle in action on moons like Europa and Enceladus around the giant planets. But to find such potential oases within the asteroid belt opens up a new frontier for astrobiology much closer to home. Each time Elst Pizarro vents its ghostly tale, it is more than a spectacle, it is a message. It tells us that the solar system is a wetter, more dynamic, and far more interesting place than we ever knew, with secrets of life's ingredients still locked in the dark, rocky hearts of our closest celestial neighbors. A cosmic engine just roared to life in a distant galaxy. Astronomers have nicknamed it the Tasmanian Devil, and its ferocious energy output is rewriting the rules of stellar death. This object, officially known as a T2022 TSD, began its performance with an initial flash of visible light so brilliant it was categorized as a luminous fast blue optical transient, similar to the cow we encountered earlier. But that was just the opening act. What happened next left scientists in a state of pure astonishment. Over the following months, this single point in the sky produced dozens of the most rapidly repeating radio bursts ever detected from such an object. These were not the singular blasts of a typical fast radio burst, but a relentless, storm-like series of eruptions, each one a tremendous release of energy packed into milliseconds. It was as if a stellar corpse had a twitching, hyperactive nerve firing over and over again. The sheer speed and repetition of these radio bursts point to an engine of incredible power and stability, something that can produce multiple cataclysmic events without destroying itself. So what cosmic creature could possibly be at the heart of this frenzy? The leading suspect is the violent birth of a magnetar. Imagine a neutron star, the ultra-dense remnant of a supernova, but born spinning with frantic speed and possessing a magnetic field trillions of times stronger than Earth. This newborn magnetar is a powerhouse of almost unimaginable intensity. One theory suggests it formed from a rare type of supernova where a massive, rapidly spinning star collapses. The resulting magnetar's immense magnetic fields, combined with its rapid rotation, could be acting like a cosmic dynamo, periodically releasing stored energy in these brilliant, repeating radio bursts. Another compelling possibility is even more destructive. The Tasmanian Devil might be the result of a star being shredded by an intermediate mass black hole. In this scenario, the tidal forces from the black hole would rip the star apart, and as the stellar debris swirls into a vast, hot accretion disk, the chaotic interactions could trigger both the initial flash and the subsequent radio storms. The repeating bursts could be caused by chunks of the star's core falling onto the black hole at irregular intervals. The Tasmanian Devil gives us a front row seat to one of the universe's most extreme laboratories, a place where the fundamental physics of magnetism, gravity, and matter are pushed to their absolute limits. The evidence for a magnetar at the heart of the Tasmanian Devil is written in the language of its radio bursts. Each flash was not just powerful, it was highly polarized, meaning its radio waves were oscillating in a tightly confined, organized plane. This is a classic signature of radiation generated within an intensely ordered magnetic field, a field so powerful it forces light itself to march in lockstep. Only the environment around a newborn magnetar provides conditions this extreme. Furthermore, the bursts evolved with breathtaking speed, their properties changing dramatically from one flash to the next over just a few days. This rapid transformation suggests an engine that is settling down, a frantic dynamo that is quickly stabilizing after the violent shock of its birth. Imagine the birth pangs of a cosmic magnet, its magnetic field snapping into alignment and its crust cracking under unimaginable stress, each tremor unleashing another brilliant pulse of radio energy. This entire event provides a rare, real-time window into the chaotic moments following a supernova that does not just destroy a star, but forges a new kind of celestial object. By decoding the frantic signals from the Tasmanian Devil, astronomers are piecing together the final moments of the most massive and rapidly spinning stars. These are stellar deaths that do not end quietly, but instead leave behind a whirling, magnetic corpse capable of lighting up the cosmos with its furious energy for months on end. Far beyond the scattered ice worlds of the Kuiper Belt, the solar system holds a secret at its dark frontier. The evidence for this secret is not a direct image, but a ghostly signature written in the distorted paths of tiny, frozen worlds. Astronomers call this the Planet 9 hypothesis, a tantalizing idea that a massive, undiscovered planet is shepherding the outer solar system with its immense gravity. The clues come from a group of extreme trans-Neptunian objects, small icy bodies with orbits that take them incredibly far from the Sun. The peculiar thing is not their distance, but their alignment. Their elongated orbits are mysteriously clustered, all pointing in roughly the same direction and tilting in the same way, as if an unseen hand is guiding their paths. This orbital configuration is astronomically unlikely to happen by chance. The gravitational pull required to orchestrate this cosmic ballet points to a single, massive culprit. Based on the sheer scale of its influence, this hypothetical world would be a true giant, a super-Earth or a mini-Neptune with a mass up to 10 times that of our own planet. Its orbit would be vast and elliptical, a grand, slow ellipse taking 10 to 20,000 years to complete a single journey around the Sun. At its most distant, it would linger in a profound darkness, a frozen realm where the Sun is just a particularly bright star. The hunt for this phantom planet is one of modern astronomy's great quests, but its existence is not yet certain. Skeptics offer alternative explanations, suggesting that the clustered orbits could be a statistical fluke from our limited observations, or that the collective gravity of many smaller, unseen objects could be producing the same effect. Yet the possibility of a major new world in our own cosmic backyard remains a powerful lure. This search forces us to confront a humbling thought. After centuries of mapping the heavens, have we truly finished the inventory of our own solar system? Or does a true giant still wait in the frozen dark, its presence felt only by the subtle dance of distant ice? Finding a single world in such an immense volume of darkness is a monumental task. This hypothetical planet does not reflect much sunlight, and its own heat signature is a faint whisper in the cold of deep space. Astronomers are using some of the world's most powerful telescopes, like the Subaru telescope in Hawaii, to conduct a painstaking needle-in-a-haystack search. They scan vast patches of the sky, looking for one slowly moving pixel of light against the static background of stars, a process that requires immense patience and computational power. Yet, even with this effort, the phantom world remains elusive, leading some scientists to wonder if we are chasing a ghost. Could the orbital evidence have a different, less spectacular explanation? One compelling alternative suggests that the collective gravity of countless smaller, unseen Kuiper Belt objects could be pulling those distant orbits into their strange alignment. It is the power of a crowd rather than the command of a king. Another possibility is that what we see is not a real pattern, but a trick of our limited perspective. Our surveys of these incredibly distant objects are still incomplete, and it is possible that the apparent clustering is just an artifact of where we have happened to point our telescopes so far. As more of these icy bodies are discovered, the strange pattern might simply fade away. Whether a massive planet is finally photographed or the clustering is explained by a swarm of smaller worlds, this grand hunt is already a success. It is pushing our observational technology to its limits and forcing us to rethink the gravitational dynamics of our solar system's final frontier. The question of Planet 9, real or not, is refining our map of the cosmic dark, proving that the most compelling mysteries are often the ones that force us to look deeper. A single, powerful signal screamed across the cosmos one summer night in 1977, a burst of radio waves so perfect it was never forgotten. The Big Ear radio telescope at Ohio State University was silently listening to the sky when it picked up a narrowband signal that was 30 times stronger than the background noise, a pure, focused tone that lasted for a full 72 seconds. It came from the direction of the constellation Sagittarius, and it matched exactly what scientists had predicted an artificial, interstellar message would look like. It was not random static, but a concentrated beacon at the specific frequency of the hydrogen line, a logical channel for any civilization trying to announce its presence. When astronomer Jerry Amon reviewed the computer printout days later, he was so stunned by the data that he circled the alphanumeric sequence and simply wrote "Wow!" in the margin, giving the signal its immortal name. The search for a repeat began immediately. For decades, astronomers have pointed their most powerful dishes toward that same patch of sky, listening intently for another cry from the void. Yet the signal never returned. It was a one-time event, a cosmic shout that faded into an eternal silence. The most persistent natural explanation points to a comet. 2 comets were in the approximate area at the time, and their hydrogen clouds could theoretically produce a similar signal. The problem is that the comets were not in the exact position of the "wow" signal, and the specific frequency detected does not perfectly align with what a comet's emissions should be. Other ideas include a brief burst from a passing asteroid, the glint of space debris reflecting a signal from Earth, or an unusual plasma instability in our own atmosphere. Each theory has its flaws, leaving the signal without a definitive natural cause. It remains the one event in the history of the search for extraterrestrial intelligence that has never been fully explained away, a brief, tantalizing whisper that for 72 seconds made the universe feel a little less lonely. From diamond planets forged in stellar cannibalism to the silent, accelerating enigma of Oumuamua, the universe has revealed itself as a gallery of the gloriously bizarre. We have wandered through the great nothing of the Boötes void and witnessed the frantic pulse of a stellar heartbeat. We have seen ancient stars puffing cosmic dust and felt the invisible pull of the Great Attractor. Each of these 25 objects is a testament to a cosmos that thrives on extremes, a place where the rules of physics are not broken, but stretched into shapes more wondrous than any fiction. This incredible diversity, from the phantom push of a ghost particle to the hypothesized giant lurking in our own solar system, proves one thing beyond any doubt. Reality, when viewed on a cosmic scale, is far stranger and more magnificent than our everyday minds can often conceive. These are not just distant curiosities, they are fundamental pieces of the puzzle of existence, challenging what we know about life, death, and the very structure of reality. So the next time you find yourself under a clear night sky, look up. Let your eyes trace the faint band of the Milky Way and remember that within that river of light are cosmic cannibals, phantom particles, and mysteries we have not yet even named. The greatest discovery is that there is always more to discover. Now we want to hear from you. Which of these strange celestial wonders captured your imagination the most? Was it the diamond world, the vanishing star, or the silent pull of the dark flow? Share your thoughts in the comments below, and let's continue this cosmic conversation together.